Hello class, this is Ed Extension Program powered by Exponential Computers, prepared by Aliu Lawal, Physics Lesson 6. So if you could remember class, our last class we discussed on equilibrium, definition of equilibrium, types of equilibrium. As we say types of equilibrium, we have stable equilibrium, unstable equilibrium, neutral equilibrium. We have their conditions, and our today's class is equilibrium of forces. We are still on equilibrium. So equilibrium of forces, let's see our outlines. This is our outlines. We have definition of equilibrium forces, then parallel forces, moment of force equilibrium of a body in a liquid, then Archimedes principle, law of floatation. So this is the content that we are focusing today, class. Let us see. So when we say equilibrium of forces, definition of equilibrium of forces. So when we say a force, firstly, force is a vector quantity, which means that it has both magnitude size and the direction associated with it. If you could remember, our last previous class we discussed on scalar and vector quantity. And so force is one of the examples of vector quantity. Why? Because it has magnitude and direction. So equilibrium of force is dealing with vector. So we say it's a vector quantity, which means it has both magnitude size and the direction associated with it. If the size of a direction of a force acting on a body are exactly balanced, then there is no net force acting on an object. Then the object is said to be equilibrium. So what we want you to understand here, class, is let's say when we have two objects applying the same force to one object. Let's take for example, let's say we have a car. Two persons from back of car used to push a car, and then two persons in front of car used to push this car, and the car, then that guys that used to push a car, they are in the same year. So the guys that in front of car used to push a car with the same force, and the guys that in the back of car used to push that car in the same force. That guys used to push that car. So as they push it in the front and the back, that guys in the back used to push it. Their force they apply are the same. So that is why the car will never move. It will be in equilibrium. It will be in a stable. Why? Because they push it in a front and then they push it in a back. They use the same force that push. So the car will be in equilibrium. So let's see another examples. As you see, this is our mass 1 and this is mass 2. So they have the same weight and they use the same force. As they sting here, this lady sting here, they have the same weight. Why? Because that is why the equilibrium are stable. You see, this is stable equilibrium. If to say this mass 1 is more than their weight, his weight is more than the weight of mass 2, then this thing will go like this. So this is our equilibrium of forces, class. Then parallel equilibrium. When we say parallel equilibrium, it's a situation in which two forces of equal magnitude act on the same direction within the plane or counter forces in the middle. So when we say parallel force, from our word parallel, something that goes or opposing an object. So let's see our plan. As the plan is moved in this direction, then there are forces that will oppose the direction of the plane. So these forces are parallel. Why? Because they are from anywhere when the object are in the sky. So anywhere you can see the force are opposing it. You see, this is the force opposing it from here and from here. So this is our parallel forces. This is the force that oppose an object if it is in acceleration. So types of parallel force. We have many types of two types of parallel force. We have like parallel force and unlike parallel force. So when we say like parallel force, the force whose line of action are parallel to each other and all of them act in the same direction. The lines of an action are in the same direction. They go in the same direction. That is why we call it like parallel force. As you see, this is a like parallel force. So this object, they are moved in the same direction. That is why it is like parallel force. They move in the same direction. The forces are in the same direction. Well, as you can see, let's say for example, as you are riding a bicycle, the force that opposing you is like parallel force. Any force that opposing you as you are moving front, so there is forces that opposing you. So when you have weight, you can see before you reach the place, that forces will have that weight. So this is what we call like parallel force. Then unlike parallel force, when we say unlike parallel force, are those line of actions are parallel to each other and all of them do not act in the same direction. So this is the opposite meaning of this of like parallel force. Like parallel force are moved in the same direction, while this unlike are not act in the same direction. So let's see the examples. So this is unlike parallel force. You see, this object 1 is moved in this direction while the object 2 is moved in this direction. This object 3 moved in this direction. This one is moved in this direction. This is unlike parallel force class. So then our moment of force. Moment of force, when we say moment of force, is a force of product of a distance from point to point to the point of application of force and the component of force perpendicular to line of distance. So this is line, this is point to point, this is our point, let's say point 1 as 5 Newton. This is a distance that perpendicular to our masses. As you can see, this is first point, the point from here to here, and the point from here to here. You see, point from here to here is 3 meters, and point from here to here is 2 meters. Why? Because this one is more than this one, and point from here to here is 2 meters. This is what we call moment of force. Which moment the force is greater than the force that they leave. As you can see, this is our force 3. So this is the point of force 3. So this point, from this point, it moves to this another point. This is second point, our second point. So this the moment of force from here to here is 2 meters, and the moment of force from here to here is 2 meters. Then this is our distance that are perpendicular to our moment of force. Equilibrium of bodies in liquid. So when we say equilibrium of bodies in liquid class, we have something that comes to your mind. When we say liquid, something liquid, like water is liquid, something liquid. So equilibrium of bodies in liquid It is commonly experienced that when an object is immersed in water, when we say immerse, something that you food or place, so when it immerse in water, it becomes lighter whether in a wholly or partially immersed. There is some upward force exerted by a liquid on object when it immerses in a fluid. So equilibrium of bodies in liquid is when we put an object, when we immerse an object in a water, his weight is become more than lighter than the weight that are in a space, the one that we do not immerse in a water. Let's see some examples. So as you can see the chart, this is our object. It is solid. This is a solid. This are in a space. It is not in a water. So as you see, this is 30. His weight are in 300 gram. Let's say they are in gram. This is 300 gram when it is in a space. So when we put the same, it is the same object with the same mass. When we put an object in a water, you see, when we put it in a water, you see, from 300 on a space, so it will reduce with 100 when we put it in a water. So this is what we call bodies in a liquid class. Law of Archimedes principle. Law of Archimedes principle states that the body immersed in a fluid is subjected to an upward force equal to the weight of a displaced fluid. So when we put an object, as you can see, as Archimedes principle, when we put an object in a water, there is exerted force that will force the object. This is beyond force. This is the force that push an object to, here is 40, it will push it into 30 when we put it in a water. This is what Archimedes principle is talking. So Archimedes principle used to tell us that when we put something in a liquid, his weight is more than lighter than the object in a space. Law of flotation. When we say law of flotation is stated that the floating object displays the amount of liquid that has weight equal to the weight of an object. So when we put an object which is his weight are equally, then we float it, so it will become floated. So let's see. As we float this we float this object, but its density is the same as this one. That is why the object is not sink. You see, but this object is his weight is more than our density. It's more than the density of a water, then it will sink. And this one is partially and not more than the in a middle. Let's say in the middle. That is why you see the object is not sink and is not at all. It was in middle. So this is our Archimedes principle. When we plot an object which is his weight, an object that we plot and his weight is more than the object of a density of a water, so then the thing will be sink. So this is what we call law of flotation. Any object you place in a water, you float in a water, when his density is more lighter than the density of water, it will become in a surface of water. When the object, let us see, like stone, if you throw a stone in a water, it will sink. Why? Because the density of a stone